everyone. My name is Tyler Jones, and this is my project automatic music transcription with an emphasis on distortion monophonic guitar. So, in short, I'm just writing a Python program that takes guitar or MIDI input, runs it through a bunch of math and stuff, and then outputs a MIDI file, which ideally sounds just like the input. You know, for the guitar, I just recorded it from my laptop. For MIDI, I just use an online MIDI editor. Nice. I will explain the process in detail for you now. So, my project has a relatively simple data stream. So, obviously, it starts with the audio input, which is all WAV files, guitar or MIDI. Once those are created, they get passed to the script, and the first thing that happens is there's some cleanup, some filtering. The main two that have helped a lot have been bandpass filter, which is like limiting the range of pitches that can appear. Like if it's too high, it's gone. Too low, it's gone, right? And then the next is a confidence filter based on confidence levels that CRAPE reports, which is the pitch detection model. So basically anything below like a confidency of zero point 0.5, I don't keep. For pitch detection, it's pretty simple. There's an integrated library for CRAPE in Python. You import it, you pass in your audio signal, and it really just does the rest for you. Super simple, very accurate too, I would say. So for rhythm detection, it's a bit trickier. The method that I went with was detecting onsets and offsets of each note, which allowed me to get the duration. And once I got the duration, I would reference that with a dictionary of note qualities. So if my note lasts for like 0.4 seconds, I'm going to assume that it's probably a quarter note. And with that process, the pitches and the rhythm qualities get combined through quantization. And then that list is thrown into Music 21, which is another Python library, which is super simple. It's a couple lines of code and just outputs a MIDI file. And that's it. So here I've got two examples from the software that I've tested. I've got a MIDI guitar example and a real guitar example, both of which use the same pitches and rhythms. So theoretically, they should look the same, but as you can see, they don't. Fortunately, once you'll hear them, you'll kind of see that they're not as far off as they look. Okay, here's the first one. Now, here's the second one. The first example is perfect. What can I say? It's the right rhythm, the right pitches. Accidentals look kind of funny, but that doesn't matter. It's the same notes. So overall, I think that these results demonstrate that accurate transcription of real guitar is challenging, but it's possible. With more emphasis on testing on real guitar audio and not just MIDI, I think I can get close to, if not just as accuracy out of the real guitar as I did the MIDI. I made pomegranate tea because my throat hurts. But now it's cold. Bruh, there's 2 hours till class, and I am like 5% done with this shit, bro. Oh.